All right, so I would ask that you pay attention to your email. There's going to be an email coming out today, and I've addressed some issues in the situation we had the other day, so I don't want to just ramble on. What we've done is I'm going to make some changes in the class in the future, and we're going to make a revision to a previous assignment so that it doesn't punitively punish the entire class, which at this point, between people not doing it and people grabbing it, 3/4 of the students essentially got a 0 on last week's assignment, on week 5. That impacts your grade. There's not as many assignments as in this as a lower level class. There's only about 350 points, if I remember right. So we're going to move forward, but I want to, and we'll point out some of these as we go, why that's a bad idea. Yes, I want you to look at other people's code. And in fact, when we start in Python, that's part of your discussion boards, are you're posting your own code up for everybody else to look at. But you can't just copy and paste. And in fact, the code that got copy and pasted the most was really not well done and had a lot of issues with it. So start over with where we're at in this idea of these methods. So the methods that we use, we need to talk about those variables. And variables are only local. So if we create them inside of a method, or we inside them inside that code, they only exist in that one little spot. We can't pass them back and forth as a variable. And so we'll show you what that looks like. We talked a little bit about global variables. So there are a few times that we create a global variable. It's usually something like a constant. So if I'm doing a program that uses Planck's constant, we might have it in there. If I need pi as a constant, something that we can use throughout everywhere in the program, all of the methods, but it's not the way that we want to move data back and forth from our different items. So we talked about the term parameters. So we can pass by parameter, so we send a copy of it to the program, and that's what we most of the time do. So there is another one that's called passed by reference. And it's also got some other names. But that is, you're really pointing not to the value, but you're pointing to that little bucket where that value is stored in the computer. You're pointing it to a memory address. Well, Python, we don't get that level of detail. But there are some languages, the closer we get to machine language, the less like human language, where this is the way we will sometimes pass variables around. We'll say, hey, in bucket 13,437, there's a variable, and you can get the data out of that and use it in your program. It's a little less common way to do it. And as we get more towards encapsulation, more towards abstraction, the less we do that particular thing, and we actually look at parameters. We can also do something really neat with parameters in that we can send multiple parameters back and forth, or multiple variables, or the contents of variables in one thing. So all we have to do, we separate them by commas, and we'll show you what that looks like. So we can pass any number of variables in. The data from the variables, not the variable itself. We can pass those in to into our argument, sending them out to a program. We can also return multiple. So we're going to look at that, the return type, and some other things. So I actually have a program code I want to look at. And sometimes it makes more sense if we actually look at the code. And I have it listed, I say it's solution to problem 3. So it's in week 6 folder. And it's got one issue in here. Some of these, notice the apostrophes. So all of these as apostrophes or strange characters didn't translate well. And that's one of the issues we also have, is making sure we always use a text file. And Blackboard likes to scramble things up. It nicely did that in this one when we uploaded it. But for what we're going to look at it, it'll be perfectly fine. So prompts a user for a social security number, name, income, and then computes your tax. Appropriate. We're at that most evil of all times, tax time. Tax calculation, the output are in a separate module. Tax rates are based on a table. So we have a little bit of details we have to deal with. And most of you know tax rates depend on how much income you make. And this program, we do something a little weird, and we just assume if you magically make $70,000, all of it is taxed at 28%. And that's not really the case. But it gives us a way to look at different tax rates. So if you make $100,000 and up, you pay 30% in tax. If you don't make over $14,999, you pay 0 tax. All right. So we know that we're going to do a couple of things. So I want to kind of walk my way through some of these. In the declarations, I'm going to have a string for Social Security number. And you may think, well, wait, it says it's a number. Why don't I put it in as a number? Well, in this case, we're using it as an identifier and as a string. We would also put some validation to make sure that it's the right length. But if you had a case of a Social Security number being 000, it would only come across then, if we did it as an integer, as the last however many numbers. So we're just going to take it in as a string, and we can just hold it in that because we're not doing any manipulation with it. We're not adding 2 numbers to it to try to figure out what somebody else's Social Security number is. We're just using it as an identifier. So we're also taking in their name. And again, we would also probably expand this a little bit. If we really were working with a tax program, it would ask for first name, last name, address, and all of this. So this is just a very simplified version that we could then explore. All right. So we also have a variable for income and tax due. And we may need some others, but I want to look at these first and see where we are going. So obviously this program is going to ask for your Social Security number. So we output, please enter your Social Security number, and then we input Social Security number. And we really put that in a loop because we want to make sure that our reader inputs some value. And so what we've created is this loop here that says while Social Security number does not equal 0. So 0 is our way to exit out of this program. So as long as they don't put in just a 0 for Social Security number, this program will continue to cycle for all of your employers. So they've entered a value. Enter your name. Put in their name. Now, we could run while loops to make sure you actually put in a value and not just hit return and put a blank. But it's probably a little less important at this point. Enter annual income. And then we calculate something called tax due is equal to tax calculations. And anytime I see those parentheses, oh, wait a minute, it's a function. So that is actually how we are getting that value tax due back into our mainline program. So tax due So we have one here called tax calculations. So this program figures your tax out based on those brackets. So remember those brackets we had? Well, what we're using is an array. We put all those values in, and we have a parallel array so we can figure out the income tax rate. So rate brackets. So here's our increments. So we can actually use that as our way to identify which bracket we're going to pay into. So we get this clunky piece out of our mainline code, and all we do is we send it some values. And we say, all right, here is their tax rate. And so here we have to figure out a little bit of magic. And this solution is missing something. So up there, I call the tax calculations, but we've said that that value that you just put in for income, how does income get down into this function? Just by magic? As we've said, that value isn't going to work. So we constructed some variables down here. So we constructed one called tax, and we constructed one called brackets, and so how do we get a value for income? So we use it down here, right? So how do we get that value down there? What are we missing? So up here at the top where it says tax calculations, I need to send in, so here, just by simply saying I'm putting in that parameter, I'm putting in that parameter of income, I'm actually sending it back out to this function. So do we need other data in this function? Because your income tax is based only on your tax. It's not based on where you live or your name or anything. I think we should base it on name. Those people with names with A through G get taxed less than the rest of you. We could do that. We don't need to necessarily in this particular case. So we have to be able to pass that down into this function, and that's how we redo that. Well, what we're also doing is we have an internal variable here called tax. We declared it. I can't see tax in my main program because we've isolated or encapsulated those functions. But notice what it does at the very bottom. It says return tax. So tax gets passed back up into that function and then shoved through that assignment operator into tax due. So we can't see tax, but we can send that value to it. And that's why we have that set up where that we actually call the function from an assignment operator. So we know that we're going to return tax. It's going to move up into that formula up there and get sent out to tax due. We don't need to use the same name. And in fact, sometimes it's confusing. Honestly, I could probably should call it something else down here instead of income, because it's confusing when I use the same names, because then you think, hey, I can just send that variable back and forth, and I can't. So the variables here aren't the same as the variables up there. Even if I had an income down here, or I used tax due, they're not the same variables. And that's where it gets a little confusing. Because this code here, this section of our method, it can only see the variables we create in that section, unless we explicitly declare them as a global variable. And there's nothing in here that we necessarily are going to need as a global variable. The only exception might be, honestly, I might make those tax brackets a global variable just because that way we could change it if we used it in multiple methods. That would be the exception to that. Correct. That it does. So it's just like a math function when you guys did algebra. Those things inside the brackets are what you send into that function. Remember brackets. Oh, and this here, rates, you're counting through those brackets, so it just moves it to the next line. So because it's a range, you're going from 0 to 1. So it's saying you're less than that next bracket up. That's all it does. And we could do that 100 different ways, honestly. We could do that. So yeah, anytime you send data in, well, we do this all the time. So if I open up Excel, and I like to use an Excel as an example, most of you have used Excel extensively. If I want to create a function in Excel or use a function, so equals sum, sum is a function, how do I tell it what data gets passed into that method sum? It goes into brackets. So what this really does here, that's a subroutine or a method. We're saying you have this data, 12 plus 14, and it's getting passed into a function called sum, and it returns that value back then to that cell. So this is really the same thing as what we've done. So that 26 then is that output going back to us. Back to that tax calculation. Or so in here, if we looked at this and we said, all right, we have a tax of, let's just make it $100,000 because that's an easy calculation. You put in your name, you made $100,000 last year. That'd be a nice salary for a year. I'd have to cut my lifestyle down and not drive a 2007 Prius, but yeah. So you make $100,000 a year. It passes that down in to this function. Boom, income gets used. So calculates that rate. That rate's going to be the 30%. We're going to come down here and say tax equals income times rate. Well, that rate is our 0.30 is what the bucket is going to pull out. So now our tax is going to be $30,000. We say send it back up, and the tax says, here's your $30,000 tax bill. I don't want to see a tax bill for $30,000. That frightens me. Luckily, I have to work hard to get my income. No. We pay so much tax, it's not even funny. My wife, because I do some consulting on the side, my wife does, so when we go to tax time, it's a very painful experience for us to go there. It's not good. It makes me sad. Now I think I need to cry a little bit talking about taxes. So that's how we move data in and out. So the return says, all right, I'm going to send that data back. When I put it into the brackets, that's passing it in. So I can pass other things in. So I could pass in another value. So I don't have to be limited to just, there it is. So I could pass in name, because maybe we really did decide we're going to tax rate change you based on your name. I will tell you one that does change, that is kind of odd, is your tax rates for a lot of things change based on your geographic location. So state tax, we figured that. State tax would change based on what state you were in, and we could use a zip code to identify that. So now we're actually passing in two variables. So tax calculations gets these two variables and says, all right, I'm here. Now what I didn't show you is down here, usually we identify it and say, okay, we're getting a value, so income, and again, we don't have to call them the same thing. I could call it X. And in fact, a lot of code's written that way, where you have X's, I's, J's, and these unnamed variables that we don't know what they do. It takes a little more time to write out a variable, but I might change this to that explains a little better what I'm doing. Now, right now, that name doesn't do anything, but I'm sending it into that function. And it's now available in that function after I'd have to declare those variables, but we can use it that way. So, it's just how we pass back and forth. Python, you're going to find out, is pretty easy in terms of this. There are some languages. If you use C++, for example, kind of a little lower level language, passing variables is very strict. You have to do very specific items to do that. Python makes life a little easier for us in a lot of cases. So the downside of that is because it's easier, when we write code in groups, we have to be very certain that all of us are on the same page in terms of how we're passing variables and information into particular items. So this is just an example of how we can do that and how this can work. All we did was pass data in. All we did was then return it back. So return means it comes back in. If we put it inside those brackets, and that return passes back into that function and gets shoved into tax due. Honestly, with Python, if we manipulated that name somehow and we return the name also, so return tax, return name passed to function. Because what we're going to do in here is we get a name, and it's going to add to the word your name. It's going to add now you are broke. It's going to pass that back. We could take two values out, and in here we can actually even do this, where it actually takes two values back and shoves them into two different variables. So now we're saying we're sending these values in, income and name. We're returning a tax due and a modified name. Because that modified name says, hey John was your name originally. Now your name is, hey John, you're really, really broke. So it would be silly to modify the name, but I'm just showing you how you could move from one spot to the other. So we're just sending values in and out, back and forth. So the other piece that I think is interesting, and we use these all the time, is we use ones that are already written. Well, again, as a programmer or as a person in here, part of the reason I'm in IT is I'm lazy. I want to automate the world around me and make my life easy. Now, sometimes we make it harder by doing that, but I don't want to have to use a piece of paper to write down my grocery list. I want to say, hey Alexa, add milk to the shopping list. Well, the same way here, I don't want to recreate the world every time. And most languages have a lot of pre-built functions already in there. We have functions that will manipulate numbers. I don't have to tell the computer in most languages how to add two numbers together. I can call a function. It's just like in Excel, I called that sum function. Well, I'm going to do the same in most higher level languages. I'm going to call a function to add up a string of numbers. Or I'm going to call a function to manipulate text. Or I'm going to call a function to put my results and output them to the display, or to print them if I want to. We have all these different languages built in, and so we need to be able to use them. So pre-written methods are available in almost every language. If we go to Python, you can see that library of everything that's available. There are hundreds and hundreds and hundreds and hundreds of them in almost every language. So we don't need to reinvent the wheel. We can cheat. We can use somebody else's code. And it's good because that code has been tested over and over and over again. Those libraries are really, really robust. So you need to know a few things about it, though, if I'm gonna take one. I need to know, well, its name, obviously. It's a little hard to call something if I don't know its name. What it returns, what it needs to take in. Well, we see this with Excel. So if I'm going to do something in Excel that's a little more complicated than a sum, so I'm going to use something like net present value. And from finance, what is net present value? Do you guys remember, or if you had it? It's kind of that value of what something today is worth if you have streams of cash coming in the future. So if you win the lottery, does anybody want to win the lottery? Or yeah, we all do, I hope. And most of the time they want to pay you, instead of paying you the $1 million, what do they want to pay you? $50,000 a year for 20 years? So if you look at America's Got Talent as an example, that's how oh, you're going to be $1 million winner. Well, no, you really, if you read it, you win and you get $20,000 or $50,000 a year for 20 years. Well, that totals $1 million, but with time value of money, it doesn't equal $1 million today. It's about $300,000 today. Its net present value is about $300,000. Well, it's a lot easier for that show to come up with $300,000 and set that up so it pays out over 20 years than it is for them to come up with $1 million. And it sounds way cooler. You're going to win $1 million. Okay, well, whatever. So net present value is one. So it's got all this verbiage up there, so it tells us we need to put in a lot of different things. It's based on a discount rate and a series of future payments and income, which are positive values, and outgoes. So net present value takes in a lot of different pieces. So I need to put in all of those items in there. So I need to go and research what gets passed in to this method or this pre-built module, and I need to know what it returns. Does it make sense? Is that the value I'm really, really looking at? And one of the odd things with this one, for example, put that in there. So the net present value in investment based on future payments, which we input as negative values. So it's got a weird quirk in there where money we come in or we're coming into us shows up as negative values. Payments we make out go in as positive values. And if I don't realize that, I'm going to end up with a number that's different than what I anticipated. Same way with any of these libraries, I need to know exactly what I need to put in. I don't usually see the code behind the print statement or the output statement. So I need to know what's going on with them and what I'm going to do. Now, the ones we're going to use are pretty standard. We're not going to get any of the really esoteric, weird ones. But we need to know what goes in there. And even a print statement differs. And so I will tell you one of the things, I'll give you this warning up front. You're going to be tempted to go look at stuff online again. There are solutions to some problems, and they are written in an older version of Python. So I said there's a big split between version 2 and version 3. So last year I had several clever students who found a solution very similar to a problem that I had written. May or may not have done this on purpose, but their code was written in version 2 of Python that we don't cover and we don't address how to deal with it. So at the very beginning they had print statements, and print statements have changed from one version of code to another. And so their code was not going to run ever, and at least in a 3x compiler. So it's kind of that, yes, I want to see how other people do things, but you can't just grab it and take it there. So this week we're working on those ideas of methods. So your assignment this week, we're going to take a look at a piece of it. So you need to make sure you have Python installed. Next week we hammer into Python. So you need to have it available on some form of platform. It will run on almost anything. You can actually run it on your phone if you really wanted to be, well, have a painful typing experience. I don't know how well it's going to work. But there is actually a Python compiler for about everything. At python.org, there's ones for the major languages. Not Python. So I can simply get it. I go to downloads. And it actually tries to identify what computer you're on. And here it says, oh, yep, you're on Windows. We're going to give you this one. If you have an older version of Windows, you're going to find that some of the later versions aren't going to necessarily play nice. Windows 7 is probably okay, but if you're on a really old machine and have Windows XP, probably not going to work as well. So you might want to be aware of that. So I'm going to look at all releases. Here we have a version for Python, or for different versionings. So if I want to look at the latest version and I want to look and see what the differences are, it tells me all about it. So 64 Mac users, it gives me notes about it. And then I have a file for all these different types of operating systems. So if I'm even using something called Windows Embedded, if I'm stuck on something really odd, I likely have ones in there. About the only thing that I haven't found that you can really run Python code on very well is at one point Microsoft came out with these Surface tablets that ran something called Windows RT. This abomination, and I haven't found distributions that'll run on that. I happen to own one because I got suckered into this idea. It most of the time just sits in a corner and I want to throw it against the wall. But if I have a Mac, they're there. And I have a Mac in my office. I just updated to Catalina, and I'm going to try it and see how bad it is. My Mac is painfully slow. It's from 2011, and I haven't decided that I'm going to spend the money to update that yet. But it'll certainly run some of these. So Mac OS X, if you happen to run Linux of some version, there are almost always ones. The other piece that is interesting with Linux, and even, quite frankly, on the Mac, because the Mac actually is based on BSD at the core, Python's actually embedded right into the operating system. And we can actually run it as a script right at the operating system level, which is kind of cool. So that's another reason we like to do that. So I want to look at the assignment for this week and see if we can come up with some ideas for it. So this assignment says we're going to design the pseudocode for the financial office of Peru State College. To make this easier, we're going to have set tuition amounts for different majors. So we're going to change how Peru State College works. Normally we pay by the number of credits you take, but we're going to change it to a little different model. You get one set payment based on your major, and that's your tuition for the entire year. And I set the tuition fairly affordably. $1,000 for our school. Education's $900 in arts and sciences because, you know, they like microscopes. They're at $1,200 a year. So we have 3 different tuitions amounts. So what you're going to do is very similar to our tax program. You're going to have to identify how you're going to take somebody, ask for their major, and then return a value based on that answer, and you're going to do that in modules. So you're going to have at least 3 methods in this assignment. So 3 different places you're going to call a method. And you can do it in any number of ways. Any number of ways. Okay, so your code will only have one start and stop. So I'm gonna go through and we're gonna look at one. Start and stop is on the mainline programming. Everything else is going to be some kind of a module that you're going to identify with a header, and it's going to have a return of some sort. Yep, the method starts with this is what it's going to do. So sometimes, and when we start into Python, it's kind of handy to have a template you're going to use to start with. Rather than always starting with a blank file, that thought of, hey, I need a template to start with is a good idea. And part of that is I'm going to put things like my name, my course number, and all these things in the header. And I'm going to put in any other things we're going to use kind of as a consistent basis we're going to have in there. So in this case, we know we have to use 3 methods, so we got to think about how are we going to do that. Well, we looked at a tax program, and that might give you an idea. But a method doesn't have to be overly complicated. So one of the methods could certainly be your instructions. So it might be a page full of instructions that you're going to use to tell them what's going on with this program, what you need to enter, why they would pay differently. So that's actually a really good use of a method. Anything I can take out of this mainline code so that my mainline code is really, I'm going to do X, I'm going to do Y, and I'm going to do Z. So it makes it easier for us to understand. When I tell you to do something, and my example I always use is something like go take a shower, I don't tell you to, I say, hey, go take a shower. And that that would be a call to a method you're going to use, and then that method would be all the steps to, you walk into the bathroom, you take off your clothes, you get in the shower, you soap up, you rinse, you lather, and then when you're done, you go back to the mainline code. Well, we don't want to put all of that in our mainline code. We want our mainline code to be very tactile. In other words, you can see exactly what's going on. We all know how to take a shower. The computer's not very smart. We have to tell it all the directions to do that, but there's no reason for that to be in our mainline code. So when I think about this problem, one of the other things I want to think about is scalability. I don't want to think about, hey, I just solved this problem and I don't have any other way to ever solve a problem and expand it except by rewriting a lot of the code. I'd like to very simply expand the code. So what I'm saying is, what if we added 4 new schools here? Could I easily change this code to accommodate them? So if my code were, let me find my text document again. So if the way I were identifying their rate, let me scroll down. So I could certainly do it this way. I could say, if major equals School of Professional Studies, rate equals, and I could hard code all of this, and that's all bad. And then I could have another line. So I could say if major equals A and S, arts and sciences, rate equals whatever we had for that one. I don't remember, 1200 maybe. And I could do if major equals, and I could do that in a series of if statements. But is that scalable? If I go from 3 to 500, is that scalable? No. So that idea of putting them into an array, I can change that array size and make it bigger very easily. So I could have a set of parallel arrays, and I could have those parallel arrays. So one could say major. And right now we have how many majors? 3? All right. So even that, when I hard code it, is there a better way to do that? What if I said number of majors? So I have that set to a variable. So right now, I really want to put that in and set this up. So I want to declare this as a majors would be a string. Major. And I'm going to put it in, so I'm going to assign it as so that takes a little more effort to do, but now I can also do a numeric string for tuition and I could do number of majors. So what I've done now is I have 2 parallel arrays, each with 3 buckets in them, and so I could put the majors in one, the amount of tuition in each one, and I could change it on the fly. If I change this by one change, now I could have 6 majors in there. So it's much more flexible to do that once we create it. So now I've made 6 buckets in each one. I link them by that subscript when I search for them. So if it's subscript 2 for the number of majors, then it's also subscript 3 for the tuition. So let me put this in Excel just so it makes maybe some more sense. So wipe out what I've got. So I've got these, and I'm going to label it bucket 0, bucket 1, bucket 2. So right there are 3 buckets. And so our major might be, I'm just going to shortcut on professional studies, arts and science, and education. They have a tuition of So now, when I want to go find those, I have this ability to do those. But I can add to it by making that one change. So now I could have 3, 4, 5. So now I've got 6 buckets. So maybe we had a school of engineering. We added a school, what other ones are there? Nursing, off the top of my head. And maybe we made psychology its own. And now we could say, all right, education, 900. Engineering, though, is really expensive, so it's 2,500 a semester. Nursing, well, we know they're going to be able to get a job right afterwards, so we're going to do 1,500. And psychologists have a hard time finding a job unless they get a master's and or a doctorate, so they're only $500. And some schools are actually doing that. They are basing the tuition looking at what the expense, so engineering has a lot of tools and equipment and things that require it to be more expensive, but they're also basing it on what the outcome is for a major. So many schools, business programs are significantly more expensive than education because of the outcome of the student. MBA programs at a lot of colleges are that way. MBA programs don't require a ton of extra resources compared to an education master, but in a lot of schools they're twice as much to get into the MBA because they're expected when you get an MBA that you're going to make a larger salary. So now we've expanded that, and that's that idea of flexibility. I didn't have to change any of the code except change one number to change that from 3 buckets to 6 buckets. So that's where we talk about that scalability and being able to reuse things is that way. So now we have those buckets, whether it's 6 buckets or 3 buckets or 1,000 buckets, the code will actually work very similar. But if I had 6 buckets and I'm trying to write all these if statements, well, I'm going to have to go in and rewrite a whole stack of those for every one of those majors. And that's not really a great way to do it. So I want to think in terms of modules. How can I make this module reusable to do that? So this is not a great way to find that tuition. There are better ways to do that. So what I might have, so I'm going to start my code up here. So I know I'm going to have a start. And the other piece I've seen before is we're having a little trouble making sure we always indent. When I use a start and I indent, that says all of that is in one block of code. That's all part of that block, and that's that level of its indentation. Python, that's how it tells most of its structure, is by indentation. So if you're not doing it now, you're going to have problems later on. So a stop, though, is at that very basic outside layer. So we have a start and a stop. Our methods, so even in our example here, notice we have our start, and we have these come down here. We declare it. So here's a numeric tax calculations. So it's going to create something numeric and output it is what it's really saying. Here we've also added this name past a function, but we were just showing you some of the ideas in there. So a function is always going to kind of tell you what it's going to pass out in most languages. So here, I may have a function called num, just saying we're going to output it, and that function could be called tuition pricing. So that's the name of my function, tuition pricing, and it's going to be a return, and we would probably want to have some variable for it to, so maybe that's tuition price. So that's our whole function. Even though we haven't done anything in it, we've created a function. And we could call it from right here. So we could say payment is equal to tuition pricing and if I don't need to pass anything into it, it's just open and close quotes. Now, does it actually do anything at this point? It doesn't, but it's got our function, and it's going to return something called tuition price. Now, I really need to declare all those variables down here, so this is also going to have a so all the variables we use inside of here, so tuition price is going to be a numeric. And before we modify it or change it, it's always really a good idea to set those equal to 0. Kind of that housekeeping garbage collection, just you never know what it's actually looking at. So now I've got one variable in there, tuition price. It's going to return that tuition price. Tuition price is going to come back in here and get shoved into payment. So right now, if I ran this code with nothing else done, payment is going to be equal to 0 because it's 0 down in that method as price gets sent back up in a loop up there to payment. Yeah, I would have to declare that. So I would want to make sure that's declared. Payment, and I'm going to set it equal to 0 up here also, just kind of that garbage keeping. So in this case, I get a value back, and it says you're going to have 0. So if I had another statement that said print your name and your payment and everything, but what this allows us to do is up here, I know that I just created something that sends off payment. I could have another module. Maybe I call this one, I'm just going to make up some variables, name, address, major, whatever else we want to get out of these students. And we could do NUID number. And I'm going to one called get info from students. And if I don't need to pass anything to it, again, I'm only doing that. Now, so I'm doing 3 variables, 1, 2, 3, 4, actually 4 there. So I'm passing those variables back to my mainline function. So I would have a function down here called get info from students. And then everything inside of there really would be, and I didn't do it on this one. So we know that it's a block of code. It's going to also be indented. So here's where you would say input name, input address, input major, and you would want to clean those up and make it look better. I'm just trying to show you what we'd look like. So you could have a one down here, and we would also look at, now I could put in things like that address verification, so I could validate that that NUID has the right number of digits and all those different things. And I do that out of that mainline program because my mainline program just says, all right, here I'm getting their information. Here I'm getting what their payment is going to be. And I could even do another one that just said output, if I can type, output student info. And here I might pass in payment, name, and address. Maybe it's printing a bill and sending it to them. So now I'm calling another function, but my mainline code here is pretty easy. It's getting info, get their payment, output their payment to a card. So my mainline code now, I make that abstract so I can just do those 3 items. And so then I can go either reuse or create a module that's going to do that function. Does that make sense? So now my program, it's kind of like that shower scenario. I don't have to tell you how to take a shower. You can figure out the details in the methods that we're going to use. So that output could well be So here we have, what did I call it? Output student info. And it's going to take in 3 variables, right? So I wouldn't ever do this because that's horrible, but they're not the same name, and they don't have to be, and they shouldn't be in some cases because it's going to be confusing. So I just got in 3 variables based on that, what it's sending out, and I just put them into variables X, Y, Z. And so in this case, I might print X, print Y, print Z. So what that's going to do, and then I return, and it doesn't return anything. So this would then say, all right, I got all this information in another module. I'm sending it to my output student info, and it's going to print X, Y, and Z, which is the information we send in of payment, name, and address. Let's see how we don't have to use the same names. And in fact, we usually don't. We try to tweak them differently. But if all this module does, that output module, is it prints out 3 values, we may want to use something like X, Y, and Z because it may also be used in outputting another item where it's also a payment, name, and address. So maybe it's also sending bills to vendors. And it's agnostic of what that name is. It's going to get the value for the payment, the name, and the address and print those out. Now, we would want to clean that up quite a bit, and we don't have addressed how you're going to create that major as to a salary. What I'm going to suggest is something we're going to do a lot when we get into Python. To make your comparisons easier, I'm going to suggest you also create a menu item for the person doing that. And that could well be in this instructions, or it could be somewhere else. But rather than trying to compare, if you get into a form and it said, you have to type in what school you are you going to type in School of Professional Studies or School of Arts and Sciences? Probably not. So a menu item then says, well, let me see if I find a spot empty here. And you've probably seen something like this where it says, press 1 for School of Professional Studies, press 2 for School of Arts and Sciences, press 3 for School of Education. So this way your user doesn't have to type in that, they type in 1, 2, or 3. And again, it's expandable. We could make that programmatic, but for now, if you just had that, you could compare, if the value is 1, then tuition is whatever that price is. So that might make your comparison a little easier. But if I'm going to write out all those instructions, I'm going to probably put those in an instruction method, so I don't have to see that up in my mainline code. My mainline code is get information, process it, and send it back out. So this problem is not unsolvable. It should be fairly simple. I would look at, when you're looking at how do I do those comparisons, Project 3, the answer to it is obviously a solution. So that's right here. I have another one here. So this is another example of a very simple little program. This one says, I'm going to get a username. Name equals ask user for name. So that ask user for name is my function down there. And it just returns a name. But again, we could expand that. We could add a while loop in there. So as long as they kept hitting enter instead of putting in a name, it wouldn't work. It would reset back. But this is a little simpler example of a program using a function that you can use as an example. So the way I would address this, if I were given this problem, is I would think of the high-level functions I need, kind of like what we did here. I would think high-level first. And so before I even did any of this, what my stuff is here, I would think of, all right, I need to do some way to do instructions. I need to get their NUID. I need to figure out their pricing. And I need to somehow output it to it. So once we get that stage, this piece is done, then you can go in and create the module based on what those actual needs are. So this is what we call abstraction. We're trying to write it high level, so the thoughts that we have, and then we can start translating to how it actually works. So if I think about like that tax program, calculate tax price. Well, if you're like most of us, we don't calculate our own taxes. We send it out to somebody. So it's whether we do it ourselves, whether we send it out, it's immaterial to us. We're not actually doing that calculation, so it wouldn't be in the main line of our program. All right, any questions on this assignment? This is going to take a little bit of time to set down and start laying it out and trying to identify it. It does not have to be like this. You can use your own variable names. You can do whatever you would like. It just has to have 3 modules. 3 modules. And as we start working, you're going to see we're going to get closer and closer to, we're going to eliminate all of the mainline code here in a little bit. So when we get into Python, a lot of times what we're really going to do is we're going to put the entire function or the entire program into a function. So we're going to get further and further away. That allows us to grab these chunks and move them to maybe this portion here we think is really good, and we're going to also apply it to, then there's a fee section. So we can take that same code and change it just enough to change fees. So we can modularize it. So think about how am I going to be able to reuse this in the future? If I get a really clever way to ask for their name, can I reuse that code? If I had a function called askName, can I reuse it? Yeah. Yeah, we do that a lot. So there are also some built-in ones, like the print is really a built-in. So I really probably should show you that your print is almost always like this. That just shows that it's you're passing to a function called print. So the first thought I always have then is, I call this function student output, so I'm calling a function. The function calls another function. And that's pretty common. We can call a function from another function. So if I had a function for, let's say I had one that said askName. So instead of doing this, it might be name equals function. It might well be you're calling a function called askName. You might be calling a function called askAddress. So you can get as many functions as you want in there, but it probably makes it sense to break this one down into 3 or 4 functions or methods. Again, your main line is the whatever code you'd like to think in terms of that high-level abstraction, and I usually do those first. The only exception to that is if I know I'm going to use some libraries that are existing, I might look at what the library is going to do for me and then see how abstract my actual program can be. But usually I kind of sketch out, what is this program, what do I want to do, what are the important things I need. So it's kind of like solving one of those word problems in math. When you had that in algebra, you need to figure out what your information is, what you need to additionally get, how do I solve that problem, and I'm in that high level, okay, I know I need to multiply, divide, subtract, but not actually doing the operations. The operations then you send down to a module. So this program I'm going to guess everybody is going to do something different. There are billions and billions of ways we could solve this one little problem. I will suggest that using if then else statements is probably not the best way to evaluate. I would suggest putting in the majors, like we showed to putting them into an array and working your way through that array. When you find one that matches, so if you have a match, then you can use that same subscript to identify the price in that. Just like when we had the food items and we had a menu item and prices, similar structure. All right. Make sure you install Python. Make sure you work on this assignment. There is no discussion board in this one. There will be an email coming out today at some point when I was writing and working on it, and my office was a little bit of a zoo this morning with people coming in and out. This program will probably take you a couple of hours to set down and work on and think about. When you write it down and you come up with some kind of a solution, try taking data in and see what happens if you put fake data in. Let desk audit. See what happens. If I put in a major of, is that going to work? And test out your hypothesis. So you're going to have a loop or two in some of your models, I hope. So that's what we really mean by modules. We're breaking it into these pieces. Each language is a little different, so if yours does not look, as long as I can tell that it's modules, your start and stop identify your mainline program. All the modules are below. You'll see pretty quickly, we'll even throw modules into a file, a different file. They're not even in your main code. So when we start in on Python, you can actually make links to your own library. So you can create your own library eventually and use it. All right. Any questions? Going once? Going twice? Going to hit the stop button?